So here's another example. This one is similar to the last one, but has a little bit of a different twist to it. It says Mike is building a dog kennel using the shed as one wall. He has 52 feet of fencing. What should the dimensions be to have maximum area? So we still want to get the maximum area, but it's a different setup because what he has is he has a wall from his shed, and then he wants to use his 52 feet of fencing to enclose a part for the dog there. And so it's still a rectangle, so we still have area equals length times width. So we want to find our length and find our width. And I'm going to do the same idea as last time. I'm going to go ahead and let our length equal x. Our width equal x. So let x equal the width. And then we're going to figure out what does our length equal. Well, this one, we have a total of 52 feet for these three sides. We're using up x here and x here, so we're actually using 2x feet of fence. So what we can realize is that this length is going to be the total 52, but we're subtracting the 2x that was already used up for the widths. So being able to determine that is important for solving questions like this. So our length is 52 minus 2x. And so what we want to do here is we want to come up with a function that gives us the area. So before we do that, obviously realize that this could be several different shapes. I'm going to make them smaller. Here's our barn, or the shed wall. It could be long and skinny. Maybe it's skinny and long. Maybe like the last one, it's a square. So we're trying to find which shape will be best where we can use up all 52 feet. And that's what we're figuring out. We could do some guess and check and do that over and over again to help us find it. But once you're able to set this up, you can find it pretty simply as long as you can work well with your quadratic functions. So our area in terms of x, so in terms of the width, is going to be the length, which is 52 minus 2x times the width. And what we can do is we can distribute this and we get 52x minus 2x squared. We prefer to have the x squared first, so it's negative 2x squared plus 52x. And now what we're going to do is we're going to work on completing the square. The first thing we need to do here is factor out a negative 2. Factor out a negative 2 gives us x squared minus, dividing 52 by negative 2, we get negative 26x. I'm going to leave a little space here and put parenthesis. And then we're going to complete the square. So we take half of 26, which is negative 13, and we're going to square that. So 13 squared is 169. And then what we want to do is we want to multiply that by negative 2. So 169 times the negative 2 gives us 238. Wait, that's not right. 338. So we subtracted 338, so here we're going to add 338. And now we have our perfect square. So this is negative 2 x minus 13 squared plus 338. We know that this is a parabola facing down or opening downward because it's negative, and so we have our vertex, which is at 338. So this is our x value, and this is the area. And so we know that x, our width, is x, which is 13. That gives us our maximum area, and then the length is this 52 minus 2x. So 52 minus 2 times 13. 2 times 13 is 26. 52 minus 26 is 26. So the dimensions that we want are 13 feet by 26 feet. And that's our width and our length. And it didn't ask for it, but the maximum area would be 338 feet squared. The next one, the next two actually are very similar. So this first one, there's this music place, Harmonia Musica, sells 50 CD players every day at $60 each. So this was obviously written in the past because this doesn't happen anymore. Each $4 increase in price reduces their sales by 2 players. So what this is saying, hopefully this makes sense to you. So they're usually selling it for $60. They found out through somehow if they increase $4, so it would be $64, there would be people come to the store that says that's too much and they wouldn't pay that much. So for each $4 increase, they lose 2 people buying those CD players. So it says find the maximum income, daily income from the sales and price they should charge to get it. So the question they're asking is, what should they charge in order to get a maximum amount of money? So right now, what they're doing, they're selling for $60 and they're selling 50 of them. So you could figure out 60 times 50, they're bringing in $3,000 on that. Well, what happens if we increase this to 64? We go up by 4, it would be 64. You would lose 2 people. You could do 64, the new price, but you wouldn't sell 2 of them, so it would be actually just 64 times 48. And if you multiply that, you end up making $3,072. So you do increase. So there's probably, though, a point where if you go up by 15 times, so if you go up by $60, you're going to lose a lot of people. People aren't going to buy it for $120 like the 60 plus 60. So we're trying to find what's the best price we should put this at in order to make the most amount of money. So this one, we have to define our variable correctly, and what we need to do here, we need to think, what does the price and the amount sold depend on? And that depends on the number of price increases. So this is new to you, but the best way to do this is let x equal the number of price increases. Because that's the one thing that relates these two changes, the number sold and how much you're selling them for. So another thing, what we want to find is find the maximum daily income. So we have to realize daily income, and I mentioned this before, as is 50 CD players, the number of CD players times how much you sell them for is what your daily income is going to be. But the way that we can write that in words is we can write our cost per unit, so that would be like our $60, times the number of units sold. That's going to give us how much is brought in each day. And so now we want to find what are these things in comparison to our price increase. So our cost per unit sold, so our cost per unit. Our cost per unit, well, it originally started at 60, but we're going to keep increasing by 4 on each price increase. So we're not just adding 4, we're adding 4 the first time, but then 2 price increases would be 4 times 2, which is 8. 3 increases would be 4 times 3. So we're going to do 4 times our number of price increases. And then the number of units sold, originally we're selling 50, but that number keeps going down, and it goes down by 2 CD players per price increase. So we're going to do 2 times X. because you have 2 less sales on each increase. And so now we're going to take this function, this equation here, and we're going to let's just say I of x, that's our income based on the number of increases. So I of x equals the cost per unit, which was 60 plus 4x, times the number sold, which is 50, minus 2x. And so we're going to multiply this out. Multiplying this out, we get 3,000. So we're using distributive property here. Minus 120x plus 200x minus 8x squared. Combining these two, that's going to be a positive 80x. And at the same time, I'm going to put this in descending order. So I'm going to put negative 8x squared plus 80x plus 3,000. And now I'm going to complete the square because we want to maximize our income. And so what we're going to do is we're going to really complete the square so we can find the vertex of this thing, and that will help us find the maximum for this. So we're going to factor out a negative 8 out of the first two. So that's a negative 10x. I'm going to leave a space here, and we have our plus 3,000 out here. And now we want to complete the square, so we take half of negative 10, which is, we're going to take negative 5 squared. Negative 5 squared is 25, times negative 8 is 200, so that's subtracting 200, so we're going to go ahead and add 200 here. And so now we can write this in our work form. This is negative 8 x minus 5 squared plus 3,200, which our vertex will then, thinking through that, our vertex is going to be at 5, 3,200, remembering that this 5 is the number of price increases, and the 3,200 is going to be our maximum daily income. So find the maximum daily income from the sales. Well, that's our maximum daily income. Max income is the 3,200. And then the other question, and the price they should charge to get it. Well, that's our cost per unit. So our cost per unit is 60 plus 4x. Well, we want to do 60 plus 4, and our x value was 5. That was the number of price increases. And that's 60 plus 4 times 5 is 20, so that's 80. And so the price should be $80. And so there's our answer. And that's how you set those up. We let our variable represent the price increase, which related both to the cost per unit and the number sold. And then we were able to write a function, which turned out to be a quadratic. And once we have that, we complete the square to get its vertex. Now this one was a little different because the 5 was not our answer, but it helped us find our answer when we plugged it into the cost per unit or the price per unit. Our last example is similar to the one we just did. It says a trolley through historic downtown Charleston costs $6 for a round trip. The trolley system serves 240 tourists per day. The owner wants to maximize profit and observes that for every $1 increase in the price, he loses 15 customers. What should he charge? Well, this is really the same type of question as the last one, just a different situation. So again, what we're going to do is we're going to let x equal the number of price increases. And we realize that the profit, so we'll use P in terms of x, the number of price increases, The profit is the cost times the number of riders, we could say, or tourists, or tickets sold. And our cost, originally it's $6, but it's going to take the $6 and he's going to want to keep increasing by $1. So by 1x. So we can just put x because 1x is the same as x. But as he increases his cost, he loses customers. So our number of riders is going to be, they're starting with 240 riders per day, but he's losing riders. And how many riders is he losing? He's losing 15 riders per price increase. And so now we can do what we did before. We can say, well, this P of X, our profit in terms of the number of price increases, is our cost, which is 6 plus X, times the number of riders, which is 240 minus 15x. And now what we're going to do is we're going to multiply this out, complete the square to help us find the vertex, and then use that information to answer the question. The question is, what should he charge to get a maximum? So we're going to multiply this out. So we have 6 times 240, that's 1,440. 6 times negative 15 is negative 90x plus 240x. And then the last one, x times negative 15, is negative 15x squared. We will combine like terms and at the same time put it in descending order. So we're going to put this term first, negative 15x squared. Negative 90 plus 240 is a positive 150x plus 1440. In order to complete the square, we're going to factor out the negative 15. That's x squared. Dividing 150 by negative 15 is negative 10. And we have plus our 1440. We're going to complete the square by adding half of negative 10, which is negative 5 squared. That's 25. 25 times negative 15 is negative 375. So we actually added a negative 375, so we want a positive 375. And now that we've done that, we can write this in our work form or vertex form. This is negative 15, x minus 5 squared, and then adding those two together, we get 1,815. And our vertex is 5, 18, 15. So this is our x, which is the number of price increases. So we want 5 price increases. And our maximum profit, which it doesn't ask, is 18.15. Well, if we take our $6, here was our cost, was 6 plus x. Well, x is 5, so we're going to realize that 6 plus 5 is $11 is what he should charge per customer. Or per person, tourist, whatever. And so that's how you set those up. We did a couple of those. Hopefully that helps you understand how to do those types of problems.